Hey, good evening, guys. What a difference a couple of days makes. We've got rain down here, and there's a long line of thunderstorms and showers going all the way up to Minnesota. And there's tornado warnings out there this evening. Here's a look at the national map. We'll get that centered there. The green that you see here is dew point, and that's a good measure of low-level moisture. We can pick out the moisture axis by looking at where the highest values are, looking from south to north. And it looks like we have an axis running from about East Texas up to around Missouri and into eastern Iowa and Minnesota, like that right there. Got a warm front. A warm front is actually more associated with severe weather, tornadoes, and large hail than a cold front. Kind of surprising, but part of that is because the moisture axis tends to line up with the warm front more often than it does the cold front. Another is that the cold front tends to undercut thunderstorms, and when you send a pool of cold air underneath, that's kind of like a bunch of outflow air rushing out from underneath the storm and pretty much cutting it off there. Okay, so let's see. Let's go ahead and head into our usual products, and we'll bring up the chart. Oh yeah, let's look at the radar since we have that up there. I'm going to zoom out a little bit so you can kind of see what's going on. This is Minnesota and Iowa there, and this is part of that MCS that stretches all the way down into Kansas and Oklahoma. And right here, right around Faribault, Minnesota, we have a tornadic storm. Haven't checked on it in the past 10 or 15 minutes, but we can go ahead and do that. One thing that stands out is the discontinuity in the line. Let me zoom out, and I'm going to take off those warnings. There you go. So usually what we're looking for your garden variety squall line is kind of a symmetric appearance. But in this example, it's kind of broken up by this one storm right there. And in fact, it's got a little bit of a kind of a rotated supercellular appearance there. And right in here, that's the hook on that storm. And also another thing that we notice is the higher reflectivities compared to the rest of the line. Down here, only about 40 to 45 dBz's, and in here, we got about 50 to 55. Another thing, of course, is the reflectivity gradients. If you look along the leading edge, not much of a gradient here around Owatonna, but if you go up north to this storm, very tight gradient right in that zone right there. So that tells you that something is going on right in that area. So now that we have a good idea of what's going on there, we can zoom in on the velocity. I like to start with the base velocity so I can kind of see if there's any problems with the velocity field and just kind of get my bearings. Got to keep in mind the radar is up to the north on this particular image. So your warm shades are air flowing away from the radar. So that's the red right there. And the blue is going to be the inbounds. So already we can see there's a bit of cyclonic shear right in that area there. Not so much in this area, maybe a little bit, and not so much here, just kind of weak cyclonic shear, but it's really intense in that area right there. So already we have a good idea where to look. Now, what you want to do with these radar products is to zoom in as tight as you can, and that's hard to do with a lot of web-based products, and that's the reason that a lot of us use tools like GR Level 2. See, we can really zoom in on that and start looking at the individual pixels. Because a tornado only has a scale of maybe about, probably even smaller than that, something like that. That's about a quarter to a half a mile wide. So that's actually pretty large. So that kind of gives you an idea of the scales we're looking at. And a storm scale would be about kind of like that right there. So we do want to zoom in as much as possible. Now let's back that up about half an hour. Go back in time, do the time warp, and go all the way back to, let's see, right around here. This is when those cells were coming out of southwestern Minnesota. Now, one thing that we notice is that most of the velocities are inbound. It's kind of hard to see what's going on, and that's the reason we use a storm relative velocity, and that helps resolve things a little bit better. We can see the outbounds and the inbounds right there. What we see here is kind of a broad area of moderate shear, looking at about 55 versus, yeah, it's about 60 knots of shear across several miles. We roll that forward, and that tightens up quite a bit. Minus 73 versus minus 22. That's about 50 knots of shear across a very tight area. And we bring that forward, and let me just show you very quickly. That right there, that's pretty significant. That's definite tornadic shear right there. So we zoom in, and these little blue blocks right here, that's 60 knots going into the radar, and then right here, that's going to be about 30 going out. So that's altogether about close to 100 knots of shear right in that area. And it's only across a couple of pixels, so the scale of that shear is very, very tight. So very likely there's either a rapidly rotating wall cloud in that area, or a funnel cloud, or a tornado kind of in that area there. I would probably put it about right there. So let's zoom in, or zoom out, and show you what the storm looks like. Wow, that's right in the middle of that red area. So this is definitely a rain-wrapped tornado. So if you're out chasing, you probably are not going to get a good view of that. In fact, that's going to be dangerous conditions there. What we really try to look for is circulations along the leading edge of the storm, down on the south part of the storm, and this is kind of the other kind of situation there. Very bad and very challenging to chase there, and that gets a lot of chasers into trouble. Spectrum width, well, don't see a whole lot going on there, and I'll just pick out a couple more products. VIL, not showing up so well in that area, and let's try something different. Let's try KDP. That's differential phase there. And this is another way of looking at reflectivity. It's not used very much, but KDP has very good penetration of precipitation, especially when you're shooting the beam down the line like that, cutting through a lot of cells. You'll tend to get attenuation of cells as you go further away from the radar through that precip, but KDP will kind of compensate for some of that, so it can be very helpful for looking behind cells and getting rid of that attenuation problem there. Okay, let's go ahead and see what else is going on across the U.S. Get my product set up here. Guess we'll take a quick look at the hurricane situation, and it's definitely pretty quiet there. Just a couple of possible disturbances they're watching there, but otherwise very quiet. And Eastern North Pacific also pretty quiet. So not much going on there, but it's SPC that's pretty busy today, and that's what their product looks like. We have an enhanced risk area there for Minnesota. Check on the storm reports. I think that last page looked a little bit better. Yeah, there it is right there. Most of the reports have been wind damage, but up there in Minnesota, tornado. And it's not so much of a coincidence that there's a warm front in that area. And the other thing I didn't mention is that along the warm front, the winds are a little bit more backed, and that's good for helicity. That's the reason we kind of favor the forward quadrant of the surface low right there, and not so much out here, where winds will tend to be kind of veered, like southwesterly or westerly. So that's going to kind of reduce the contrast between the low-level winds and the upper-level winds, because they're going to be kind of similar, so you're not going to get as much of that curvature on the photograph like you will out in this region. So yeah, up here, ahead of the low, that's going to be your best location for tornadic storms, and then down here the atmosphere is a little bit less sheared. All right, so yeah, let's see. Watches, got a couple tornado watches for Minnesota, Wisconsin, and then from Iowa southward, that's going to be severe thunderstorm watches. Okay, the upper levels. Let's see what's happening up there. Let's go up to 250 millibars. So this is jet stream level, 34,000 feet. And we got a much different picture today. We do still have the Canadian polar vortex up there, centered around Baker Lake there, and then the polar front jet really picking up, getting about 160 knots up there in Ontario, and we have this very strong wave moving through the northern Rockies. So do we have a subtropical jet? It's possible right there over Arizona. We got some winds coming through this area right here, and let's see, 60 knots there in Nebraska, 50. That could be a subtropical jet kind of linking up with a polar jet up in this northern area. One way to also pin down things is to look at the lower levels. 500 millibars will typically show the polar front jet, but not the subtropical jet. So let's see, Arizona, kind of light northwesterly, and the winds pick up around Iowa. I'm not too sure that a subtropical jet is associated with this. This may all be mostly polar front jet energy, and that's just kind of first glance there. And then at the East Coast, we've got that subtropical ridge out in that area. Let's look at the wind flow. We got southerly winds there in Little Rock. Across Indiana and Ohio, we've got westerly winds. They become northerly in Virginia and the Carolinas and in Atlanta. And then they become easterly in southern Alabama and New Orleans. So the center of that circulation appears to be right around Chattanooga, right in that area right there. So that's the location of the subtropical high. So very likely there's very warm conditions in that area, and very possible there's not much precip in that area either. Going down to 500 millibars, we can see that subtropical high stacks down vertically, still in the same area right there around Knoxville, Tennessee. And then down at 700 millibars, yeah, very same area. Subtropical highs are barotropic, and barotropic highs, in fact, barotropic systems tend to be vertically stacked. They're not going to have tilt where you find like a high here and then you go up to the upper levels and find it way over here. That is not really going to happen very significantly in barotropic systems. So that right there, when you're analyzing the chart, that tells you it's a subtropical high. Okay, and let's see if we can look at the opposite of that. Look at baroclinic troughs, baroclinic lows, that kind of thing. Let's see. Let's put that together. We'll go down to 850 and find the surface low, and it appears that's right around western Nebraska. And keep in mind this is a 12Z. That's this morning. So it appears it's yeah, on the high plains. So we go to 700 millibars. Looks like probably a trough across Utah and Wyoming. 500 millibars shows the axis of that trough pretty much through Utah. And then we go up to 250 millibars, and it appears it's in western Utah into eastern Nevada. So, yeah, if we put that together, 850 millibar low was in this area. It opened up into a 500 millibar trough further out west, and then at 250 we saw it here. So it stacks upwards, not vertically, but it tilts towards the cold air with height. So in the low levels, it's kind of adjacent to the warm air, and in the upper levels, your reflection of that low, is, in this case a trough, is going to be very close to the cold air. Okay, so that's a comparison of barotropic and baroclinic systems. Now, if you're wondering what that means, barotropic means that there's very little temperature advection. Usually the isotherms will be fairly parallel to the isobars. And then with baroclinic systems, there's significant temperature advection. It's frontal. and there's significant crossing of the isotherms across the isobars. I don't know if I can show you an example of that. We have to find it. Yeah, here we go. This is a temperature field. This is 850 millibars, and remember that low we were talking about on the high plains, 850 millibars, and then we look at the isotherms right here, and you can see there's lots of crossing of the height contours, and the winds are indicating that there's warm air advection in Minnesota, South Dakota, Nebraska, bringing up that warmer air northward into the Dakotas there. And on the other side, we've got cold air advection. So the wind flow out of the northwest in Colorado, Utah, Wyoming, and bringing cooler air southeastward into Colorado there. Okay, thickness. Let's see what's going on there. I'm taking a closer look at Canada these days because things are very dynamic up in that region. The cold polar vortex appears to be centered across the Northwest Territories there, and you can see lots of thickness contours, kind of like a big bullseye right there. And that not only indicates that the center of the cold air is right there in the Northwest Territories, but indicates that there's lots of support for a polar front jet kind of in that area, and possibly kind of a split flow, maybe another polar front jet to the south. And then the fronts, let's pin those down. There's our Bear Clinic low. That's going to be current for this evening. So there's the cold front, and it appears that extends possibly into Utah and Nevada, something like that right there. And then the warm front extends eastward into Wisconsin and Michigan. It's kind of hard to draw this with a mouse. I do have a tablet, but it's a little bit laggy. I might give it another try here in the next couple weeks and see if it works, but I'm sure that'll give better results. Anyway, yeah, the cold air is coming down through Nebraska into Kansas, and then out ahead of that, we've got the flow of warm air advection, moisture coming up from Texas into Oklahoma and northward into Missouri there. Looks like a system coming into the Pacific. If we go way out here, you see that coming together right there. That's probably one of our next systems there. That's going to be the cold front, warm front extending out into western Washington there, and surface low right in that area. So that's going to be heading into the Pacific Northwest, and we may see things start to develop in that area over the next few days here. Okay, it's probably about time to go region by region, and I've got to go to my satellite maps. Let me see if I can find those. Yeah, there they are. Roll things back to earlier today. And let me check in on chat, make sure there's no big disasters going on with the feed. Pretty good turnout. Good to see that. Let's see here. Yeah, just to show you what I'm looking at. Yeah, this is... I can see my stream health and all that, and I can see the trend going up, which is good. That means the stream is looking pretty good, and I can see only 57 drop frames. All right, so yeah, let me check out the chat here. JT there, and Sue M, Carl Burkhoff, Erica Baker. 90 degrees up there. It's hard to believe it's warmer in Kansas than it is here. David Lumbert, Arkansas, 75 over 71. Shirley Keast reporting rain up there in the UP of Michigan. Got Burl H here, and Ryan Toomey's there in Florida. Says tornadoes reported on the ground in Minnesota. Got Ben David Perez here. Adam Davis. Ryan Toomey is mentioning the Bears cage. I'm going to have to skim through this real quick to keep things moving. Thomas Coppola and Joe Desert Gardner from Are you on Mount Lemmon? Wow, okay. Yeah, I've been up there quite a few times. Upper 80s there. Okay, mid 60s on Mount Lemmon. Okay, Brian Lowe up there in Delmarva. Alexander Nisinski and Mike Estwick reporting 79 in Denver. And pilot Mule Rider is also joining us. All right, so let's go into the satellite and see what's going on. Anyway, yeah, you can see the baroclinic system moving out of Nebraska and South Dakota out in this area right here. Surface low looks like it's right. I would probably put that around the Sioux Falls area. Cold front extending southward, and then the warm front like that. And lots of isentropic lift in Nebraska, not Nebraska, but Minnesota and Wisconsin out in this area right there. So we're getting kind of an overrunning effect right there with all that warm, moist air flowing northward. And then if we animate this, remember we were looking at that subtropical high there in Tennessee. If we animate that, you can kind of see the rotation in that area. It's kind of a very broad spin in that area. And looking at strictly at satellite, it appears it is, yeah, it looks like the center is right in that area around Asheville. All right, let's zoom in a bit. Not much going on in the Pacific Northwest. That's the image right there. Very quiet, but looks like a little bit of a jet streak. See that right there in Idaho? That's something I might look for on the upper area analysis. That might indicate a very strong piece of upper energy moving through that area. Looks like the fires are still going in Utah and Wyoming. Going down to Arizona, as we've mentioned the past week, things quieting down quite a bit. The monsoon has pretty much been shut down by the westerlies. They've pretty much spread through this entire area, jet stream energy and prevailing west-to-east flow. And that's kind of pushed out some of the moisture. Looks like a few cells holding on around Globe, Safford, and down to Douglas. North central U.S., of course, lots of weather going on in that area. And we're going to zoom in a little bit on this area. I've got another sector set up, but the warm front located right there. You can kind of see that boundary right there in Iowa coming together, and then storms going up near the surface low and along the cold front in northwest Iowa and down to about Lincoln. Texas is more under tropical flow right now. There's what that looks like today. You can see lots of cells going up, and part of the reason we're getting this increase in activity is due to the subtropical ridge backing off. Typically, we do find the subtropical ridge kind of covering this entire area, but today it's kind of centered across the southeast, and that means that the lapse rates are going to be a little bit steeper in this area. Not so much suppression of the convection, and also with the Gulf being wide open, precipitable water is coming way up in Texas, and maybe we can pull up the skew-t in a bit and check that out. The Great Lakes area in the northeast is fairly quiet, strong westerly flow aloft. You can see that jet stream energy across Ontario and the Great Lakes there. And then down in the southeastern U.S., summer continues. Sea breeze definitely active through much of Florida there. Everglades, Lake Okeechobee, Tampa, and all the way up to Jacksonville. And you can see a bit of that sea breeze moving inland into Alabama, Mississippi, and Louisiana right there. And then that takes us to Minnesota. Let's back this up to earlier today. And right here we can see that warm front coming together in Iowa. A little bit of convergence showing up in that area. The cumulus building early near that front, and we roll that forward a little bit. And as the day goes on, this is going to be about 2 or 3 p.m. Warm front located right there, and you can see a difference in the cumulus field. Down to the south, we've got cloud streets, which are pretty much parallel to the flow, and then up to the north we have transverse bands. So not only can we pick out the front there, but we can pick out a difference in the texture between the cloud fields, and that right there would indicate the presence of a boundary, even if it doesn't show up right in this area. So the transverse bands right there in Minnesota, indicating that the air is fairly well capped. But of course that breaks down as we get more and more heating. The warm front moves closer to the area, and we've got pretty much all the ingredients right there for severe weather. And those are the last few frames, and towards the end we can see the cumulonimbus anvils coming into view right there, and a few of the overshooting tops right in that area there. Not much low cloud field, so the moisture probably a little bit limited. Not much going on right there. And even earlier today, very weak low cloud field. So a lot of this is dynamically forced, most likely. And we're just going to see that MCS continuing to move eastward during the evening. Okay, that brings us to the forecast, so let's go ahead and put things together. We'll start out with Minnesota there. So your valid time is going to be right there, 23Z, that's about an hour ago. And it looks like the model is initializing pretty well. All those convective elements are about where we would expect them. And it looks like they're just going to continue moving eastward right there. Looks like a second wave coming together in the Omaha area. And those will start dying off around 6 or 7Z. That's going to be after midnight. You can see some of the forcing along that cold front right there. And then tomorrow, I guess the cold front's right around there. I guess as those temperatures come up later, I would expect to see a chance of storms, probably Indiana, Ohio, Kentucky, once we get the heating started in that area tomorrow. Okay, let's see here. Let's look at the hemispheric. This is the upper levels, 500 millibars. Back that up a little bit. So starting out, what do we see here? We've got zonal flow from the Pacific across much of the U.S., kind of broken up into these waves, and pretty strong vortex up there in Canada. So running forward, that wave right there should move quickly to the east. So it looks like by tomorrow afternoon, that's going to be approaching Michigan there. Probably a lot of energy focusing on that area. So I might be thinking maybe a little bit north of Ohio, maybe, yeah, Michigan or Ontario there. Rain chances going up in that area. And then here comes another wave coming onshore. But the pattern is getting kind of noisy across Alaska, the northern Pacific there. This is kind of a block coming together. We talked about that back on Tuesday. Subtropical high still in place across the southeast U.S. And let's see what happens over the weekend. That one trough in Canada moves quickly out to the Maritimes. Very fast flow across the northern U.S. And here comes round number 2. Roll that forward. This one is digging in a little bit. So this is going to be Sunday morning. Looks a little bit active there, and looks like around Idaho up to Montana. And then by Monday, the pattern is going to be looking like this. That trough is going to be coming into the Central Plains, and I think we're going to see probably a surface system coming together in that area. Looking strictly at the upper level patterns, we can pick out where the surface systems are going to be. Okay, here's the upper trough. Here's the upper ridge. The jet is going to be located about right there. And then the surface systems, we're going to find the surface low along the jet in between the trough and the ridge, so about right there. Cold front extending southwest, and the warm front extending southeast or east, kind of like that there. So this does look active for the northern plains for Monday. It's going to be a fast-moving system there. And then we're going to see some very significant changes going on next week. First of all, this trough is going to dig in, and then we're going to see the patterns really start amplifying, and that's going to probably change things quite a bit. So here comes that trough southward, and we get that very strong northwesterly flow. So that's that polar express that we were talking about on that headline there. A little bit of a Rex block off the west coast there. So by late next week, Thursday and a Friday, we've got a very intense northwesterly flow aloft, and that's likely going to push a lot of cool air south from Canada late next week. And that pattern will be holding on through the weekend. Most impacted will be the Great Lakes, the Midwest, the Northeast, and the Northern Plains, and a little bit less impacted will be the Southeast and the Southern, the South Central U.S. And towards the very end, let's see what happens there. Kind of a continuation. This is October 5th and October 6th. A couple of very strong troughs coming down. So we're getting a definite early start there to fall. Things are going to be much different here in about a week. So we can show you the surface systems. This is Saturday, and this is on Sunday. And here we see the, let's see, hang on a second. Let me bring this forward a little bit. Yeah, here's the start of one of the systems around Wednesday. And back behind it, this is all polar air coming up off the Arctic region right there. Texas by Friday. Third in for Saturday, the 29th. And we just get these polar highs sinking in across the central U.S. More significant weather up there across the western Canadian Arctic. That's going to generate new snowfall, which is important for generating polar air. So we're going to be in this pattern for a while, probably into mid-October. That's kind of how it looks right now. So there comes the next system coming southward. And I can show you a couple of other products for looking at this. Accumulated snowfall. Haven't seen this in a while. So already by this weekend, snow track across Alberta from about Edmonton to Saskatoon. And up to the north. Yeah, look at that. Snow starting to come down in that region. So that's going to deposit snow and start insulating the atmosphere over that area, and that'll allow it to cool down, especially as these days get shorter and shorter. And we'll take a quick look at snow depth by the end of the period. You can see right there over Victoria Island up to about 20 inches of snow, 20 inches across northern Northwest Territories. So we are seeing a change here. Okay, so we can go ahead and look at the surface chart and just kind of finish things off. All right, here's that polar system coming southward into Oklahoma and Texas. Looks like that'll kind of park itself over the Dallas and Little Rock areas. There's the high right there, and you can see all the dry, cool air across the Great Lakes and the Midwest. So down in Texas, the pattern will be kind of stagnant. Looks like a little bit of a low in that area, very high precipitable waters, and looks like a stationary boundary through that area. So it looks pretty wet down in Texas. And then towards the end of the sequence, we start seeing the cold polar blast coming southward. This is on Wednesday. So that doesn't really impact the moisture a whole lot. But here comes another one. You can see the very strong gradient up there in the high plains. So this is driving south. Let me get my cursor back one more time. And there it is right there. And this one, yeah, definitely starts pushing out some of the tropical air back to the Gulf Coast there, and looks like by Monday, the 1st of October, it's going to be much drier across much of the eastern half of the U.S. Starting to get a little bit of a return flow there in the high plains around Tuesday, Wednesday. And then we get the next polar system moving southward. And then I don't know, the GFS picks up something out in the Gulf around the 6th, but that's pretty far out. Anyway, yeah, but on that very last frame, you can see up there in Canada, look at those pressure gradients up there in Alberta and British Columbia. So that's more polar air about to come down. So it's just going to be kind of a sequence, just a series of cold air coming southward. All right, so that's the story, and that's about all I got here. Let me take a look at chat. Yeah, we dropped a few frames there. Sorry about that. Well, Meteorologist gives lots of good educational detail. I appreciate that, Event Horizon. Thanks for joining. Very much appreciated. And Grant Lady says, when do you think will we start seeing a major snowstorm in the Midwest? I think that's going to be probably November before that happens. I mean, we can get some very, very cold weather, and well, I don't know. Even in Oklahoma Panhandle, yeah, there's been some very early season events. So, to tell you the truth, I don't really know. We're just going to have to wait till these systems start shaping up. But it's definitely going to be around October before we see anything like that. Okay, so that's about all I got. Have a good evening, and we'll see you later. Bye-bye.